that usually are not possible to do in the conventional tools or sometimes even Excel. So in today's session, what I will show you is I will show you how you can create a geological or let's say stratigraphic cross-section that's basically based on well by well. So if you don't have any background on what a stratigraphy is basically layers of the rocks basically stacked on top of each other, and those layers are usually penetrated by different wells, and the wells that penetrate these rocks, actually, they have very great significance in upstream applications. It gives us an idea what to expect whenever we drill new wells. So the problem with these types of chart is usually it's two things. Either you will create a very primitive chart, which is basically what usually happens if you use mediocre softwares. And the second point is if you use or if you want to create a high quality chart or maybe a chart that's interactive, you will be stumped into two main barriers. First of all, the cost of these types of software are huge, and usually it does not worth the investment if you're only trying to make cross sections or well by well stratigraphy. So this is number one. And number two is actually the limited uses of these types of software deems them not possible to be purchased by all different companies, because the cost or the investment associated with it is just too much. So in this session, I will show you how to do something similar in Python. It will be highly flexible. We can control it. And better than that, it's going to be highly interactive, meaning that the user will have the luxury to select whatever well he wants to plot, whatever selection of wells he wants to compare, and most important thing, he also can control the number of layers that he wants to plot the layers of the rock. So we will produce something similar to this. And we are going to work with a library called Streamlit. Streamlit library in Python is a very infamous library that's been recently added to the Python arsenal. This library, what it does, it creates applications for you, and it's actually a full-fledged web applications, and you can create those with very easy and few lines of code. The most important thing is it's not just the software that you create or the piece of code that you create, it's also the application that you create. It's actually shareable among technical teams. And you will know what I'm talking about once I finish the software, and then I will show you how can you access that particular software from other machines as well. So without further ado, let's go ahead and start the session. So first of all, before we do anything, let me show you what the data looks like. Because in oil and gas industry, everything is basically related to data. Without data, you can't do anything. So I have a data which called tops, and this data basically contains everything I need to do my cross section. It basically contains well names, the geological name, or let's say the name of the geological layer, or let's say the name of the formation, and what is the measured depth that this formation was reached. So these are the information that we're going to use in order to construct our geological cross-section. And you can see it's not that much of information, but the way we construct it is actually the key. Meanwhile, whenever you have a question, please feel free to ask in the chat box. I will try to answer every question, especially the technical ones. If you have any question regarding the geological cross-section and things related to that, please feel free to ask. I will try to answer those questions. Okay, so first of all, what we have done is actually we started reading those files using this line of code, which is basically calling Pandas, which is something that you have seen yesterday. calling pandas in order to read different and various things. So what I will do is, once I read the data, is there is something that I need to do is I need to actually view the data so you can see how the data looks like in the application itself. So it will be something like ST, which is short for Streamlit, which is the interface that you're working with, dot data frame. And basically this is it. And between those two parentheses, you will view the data and you will save your work. Once you save your work, you will see the application actually refreshes itself. You can, of course, maximize the data and just view the data. So what I will do is one of the columns in this data actually contains the names of the wells. And if you can see, the name of the wells contains repetitive data. For example, this particular well contains 5 rows, and each row actually is corresponding to the geological cross section or the geological layer that's basically it's penetrating. So we will start, or we will make the names of the wells our starting point. So what we will do is we will allow the user to select as many wells as he wants in order to do cross-section. So this is going to be the part where the Python excels at. So I will create this very simple variable called wells equals to data and basically the name of the wells, only the unique ones without any repeating names. Once we do that, now it's time to create a control that will allow the user in order to select the wells. So the control will be called selected wells. You can name this as long or as short as you want, or we can just use symbols for this as SW, which is short for selected wells, equals to Streamlit, which is the interface that we're targeting basically, dot sidebar is actually the location where I want to put my control, which is going to be on the left, dot multi-select. Multi-select is a function, or it's a component that basically allows you to select multiple things at the same time. This function or this component is a general thing, but we can use this for anything we want. For example, in oil and gas industry, we can use this for wells. We can use this for geological names. We can use this for different minerals. We can use this for well logs. Well, basically, we can use this for anything we want as long as it represents something somewhere in the file. So we will give this a label and we will call it please select wells. This is just a welcoming label for the user, so the user knows what he wants to select. And the next thing is actually the options that the user basically is going to select from, which is basically the wells. We're going to save this, and once we save this, you will see a new option or a new component has been added, or a new graphical interface component has been added. Once you click on this, you have all the wells that are basically listed in your file. And this wells, or the list of the wells, is basically dynamic, meaning that if the file updates itself, this application will also update itself. And this is the beauty of Python. You can select multiple wells at the same time, and this is going to be the interactive part. You can also take any number of wells you want by just clicking on those cross buttons. Everything's basically possible. You can also clear all the selection as well, like this. Now, once you have your wells already selected, now it's time to actually start generating some good things. So the first of all, what I will do is I will just split my application into 2 main pages. The first page is going to be dedicated for the filter data or the wells that I have been selecting, and the second page is going to be dedicated for, let's say, the cross section that I'm going to plot. So we will create 2 tabs. We will call this tab 1 or page 1, and let's call this P. Let's call this page 1 and page 2. Although technically this is not called a page, but let's do that for simplicity. Equals to Streamlit, the interface that we're targeting, dot tabs. So the tabs is basically those 2 pages that we're creating, and you should give this a 2 name for the first page and the second one. So for the first page, we will call this filtered wells, or you can name this anything you want, by the way. And the second one, let's call this cross section stratigraphy. Let's save this. Once we save this, there we go. You can see now you have 2 pages. So what I will do is, instead of just viewing this data frame or this table on the top, I will just delete it and I will leave the application empty for now. Once you delete that line, and save it. Now your application is starting fresh again. Now, let me show you how we can filter the table that we're getting. Basically, it's the data based on the well selection. Usually in older programming languages, what you will do is basically you will go ahead and write some advanced for loop that basically filters out everything for you. And basically in Python, you don't need to do that. It's just a single line of code that basically takes any number of wells you select or any number of equipments or assets you select, and then it will cross filter that with your table. So you don't have to do that manually. So Python will take care of that. So this is going to be look something like this. We will call this data FLILT, which is short for filter, equals to the original data and then data dot wells. Basically, we are trying to filter based on wells, and then I will call this is in. Is in is basically a function that allows you to filter based on multiple criteria. And our multiple criteria is basically our multiple wells that has been selected. So the selected wells are SW, basically on selected wells. And once I have generated new file or new table, what I will do is I will just plot that or show the table where it's going to be shown on the first page. So we will do something like page one dot data frame, just like this, and then you will be viewing data filtered out and save this. Once you do that, there you go. Now you have an empty table. Why the table is empty? Well, because you did not select any well. So if we start selecting wells, you will see now the table is being populated as I am selecting wells. Why this is happening? Because this is going to be an interactive application. It's not going to be a static application that you don't see what's happening. No, it's going to be interactive. As much as wells you select, the table will update itself. So this is the first part. Now, the second part, what we need to do is we need to create a very nice cross-section, a cross-section that's basically used in order to view different wells that are being selected. So what I will do is I will just start with only 2 wells. So only 2 wells, and then I will build up more wells to this. Okay, so this is just for me to show you what's going to happen in a simplified way. So if I open the Paint application, and basically, usually what happens whenever you draw cross sections is basically you have those well locations on the surface. For now, let's say that we have only 2 wells. Those wells usually penetrate at a given depth, something similar to this. By the way, not all the wells have usually the same depth. And usually you will penetrate different types of layers, and those layers are penetrated are usually at different elevations, or let's say that they are usually at different depths. That's why it's usually very important to understand what is the dip of these types of layer, or how the layer is dipping downward, or if it's dipping upward. So what we will do is we will connect usually those layers together and basically understand how the geological setup is basically happening in the downhole. So in the future, if you go ahead and select a new well, basically in here, so basically you already know what to expect or what depth to expect. This is what we are trying to achieve in Python. And it's going to be interactive, and it's going to be very easy to do. Now, what we need to do is we need to start plotting this. So first of all, I will create an interactive figure. And that interactive figure will come from a library called Plotly Express that I have already imported, which is on the top section. So px.area, I will be creating an area chart. So the area chart will take data from data filtered out, because this is the data that I am actually working with, which is the filtered wells. So the x-axis is going to usually be the well names, because they are going to be on the x-axis, which is something similar to what we have drawn in here. So this is, let's say this is well 1, and basically this is well 2. And the y-axis, usually the y-axis is actually the depth, or let's say the negative elevation of the geological layers. So the y-axis will be the elevation, or let's see what's the name of this table, to be more precise. It's actually called the measured depth in meters. So sorry, it's called a measured depth, which is basically in meters. So you have to make sure that the column name is correct. Once we do that, what we will do is we will use page 2 and dot Plotly chart. So this will view our chart. So this is going to be figure. Let's save this. Go to our cross section. There we go. Now this is our cross section, but our cross section is not a very good one because this needs some adjustment. And the adjustment that it needs is basically we need to tell this plot that we have different geological layers, and those different geological layers should have different colors and different lines. What the application is doing now, it's combining everything together, which is something that we don't want to do. So let me show you what we usually do. So first of all, what we need to do is we need to maximize this chart. So this chart will be taking the full screen. And once the chart is taking the full screen, what we can do is actually we can go and start customizing this chart, or let's say customizing our solution. So let's put this side by side and start working with this. First of all, what I will do is I will add, or I will increase the height of the chart, because the chart needs some height in order for the geological layers to be presented in a beautiful way. So height equals to, let's say 800 pixel. By the way, you can select any value you want. Now, once we have the height, next thing that we will do is we need to tell the software, or we need to tell Python that actually what we are trying to do is we are trying to color based on the geological name, or based on the layers that basically it's penetrated by different wells. So we will say geological name. Let's save this. There we go. Now we have started to see something that is similar to cross sections, and this is just for 2 wells. If you start adding wells, and you will see this is actually started to look something like something that you see in commercial softwares for different geological cross sections. Now, there are a few customizations that also we need to do. So one of the customizations that we usually do is actually the type of the line. The geological cross section can be 2 types of lines. For example, let's say that we have these 2 wells, and we have penetrated the same, or let's say we have 3 wells. This will illustrate the example a little bit better. So let's say that we have penetrated the same layer at different depths. Now you have 2 options for plotting these. Either you connect these layers with a straight line, something like this. So this is going to be a linear chart, or even better, you can connect those using a spline, which is a smoothed out line. Both of these options are possible in Python. So in order to do that, you can use line shape equals to spline. Spline will give this curvature to your plot. So let's save this. There we go. Now you can see there is a nice curvature to our geological layers. One more thing that you can do is also you can change the template, or you can change how the plot is being presented. Because the way you present the plot is basically it tells what customization has been done to this plot, and makes this lot more professional. So the template that we can use is basically Python allows us to select from large selection of templates. So the template that I will use, it's called none. The template name is just called none. So let's save this, and you can see now it changed the color, and the template suddenly is looking a lot better than before. The next step is what we need to do is, usually the cross sections or the stratigraphic cross section actually starts from top to bottom. And if you pay close attention to this chart, it's actually the reference depth, which is 0, is starting from bottom, which is something that we don't want to do in cross sections. It's basically, it defies the actual setup. So what we need to do is we need to start from 0 on the top, and then work our way downward by increasing with depth. So in order to do that, what we will do is we will activate an reverse y-axis. In order to activate a reverse y-axis, what you need to do is you need to control how the figure is looking like. So we will say figure layout, because we are trying to control the layout. The axis we are targeting is called y-axis. And what we are trying to do is how the numbers are arranged. And we say that this is reversed like this, and just save this. Once you do, now you have something similar to a geological cross-section that usually you see in these types of applications. So let me just clear off everything and start from only 2 wells. So let's select those wells. So canal 6X 41, and you can see now these are only for 2 wells. That's why you have only straight lines. But once you surpass 2 wells and 3 and plus, you will see those spline kicking in. There you go. Now you can see you have those splines are kicking in. You can, by the way, you can select as many wells as you want. This will give you a clear understanding what to expect in between wells once you start drilling new wells in the future, or once you plan new wells. Now, the next step would be is actually what I would love to do is I want to make sure that the locations of the wells are very clear, because what's happening now is the locations of the wells are just written as names. If you can see on the x-axis, those are just names. So what I would actually, the optimum way will to present wells is actually by drawing a straight line for each well location, something like this. So we understand what's the total depth of this well plus where the well location is. So it's going to be something similar to this. And luckily, this is very easy to do in Python. So let me show you how we can do that. Let me put this application side by side. We will start creating a bar chart, or let's say those lines that we've been talking about. So let's call this well, or W equals to graph objects dot bar. This is going to be a vertical bar for each particular well. The x-axis will come from the data filtered out of wells. So the x-axis will be well named, same as the geological cross-section or the layers that we have created. And the y-axis, it's going to be just the total depth, or let's say the elevation for that particular well. And let's go ahead and copy that, which is going to be the measured depth like this. Let's add the measured depth in. And once we do that, now it's time to add this wells locations into the chart as well. So figure.add trace. Add trace is just adding another component to the chart. So for W, let's save this. There we go. Now the well locations is now visible. What we need to do next is we need to make the width a little bit smaller. So because the width is just too large now, let's make this 0.1. So there we go. Now these are these magenta ones are the well locations. And you can see now the well locations is basically visible alongside with the geological stratigraphical cross sections. Let me expand this and let's select more wells. And the more wells you add, you will see now the more bars, or let's say the more charts has been added to your cross section. And you can, of course, maximize this chart. You can download this chart in full and high resolution. What you can do as well is you can just flip this to a darker theme. So the theme is going to be a darker one. And if you want to switch to darker theme, what you need to do is you need to change the template to Plotly dark, and the template will be dark. So it basically it caters to different tastes. One final thing that we usually do is actually I will show you how you can, once you finish up this software, or once you finish up this application, I will show you how this application can be accessed from different machines. So I will stop sharing my screen now from my computer, and I will show you how this is accessible from my tablet. So I will stop this for now. So the same, just please pay attention, the same application is running on my local network. This is by default in Python, by the way. You don't have to work for that. So Python offers that by default. So I will share my tablet screen now. So the tablet screen should be visible now. And I will start punching in the access, or let's say the location for that particular application. So the location for that particular application is already provided by Python, which is 192.168, and this is basically, this is local one. So you will have a unique one, and basically you can't access mine, but whoever is connecting to the same Wi-Fi as I am can access my application. So 100.32, and then you will follow this with a port number. And just a reminder, this is a tablet. And let me show you this in a wide mode. There we go. This is what the application looks like. And just please, a simple reminder, the application is being broadcasted from my laptop into any device that's connected to my network. And what I will do is I will select multiple wells. Once I select multiple wells from my tablet, the cross section is being generated on the background. So if we go to the cross section tab, you can see the cross section is already generated, and you can of course interact with this cross section. What you can do is you can take or download a picture for this. It will be downloaded on your machine. There, we can open it as well in our image viewer. There we go. Now this is the cross section that we have captured picture for. Plus what we can do also, we can zoom in for this. We can select on any range of well locations like this, just drag and drop, and basically it will change the view, and you can revert back to whatever have you been doing. So let me just view back this application again. So the title for this application is called Well by Well Stratigraphy. Let me show you what will happen if the application is updated. So if the application owner, which is me on my computer, if I update this, the user will get a notification for the update, and it will ask, do you want to reload this or not? So I will change the title from Well by Well Stratigraphy to just cross section. And once I save this from my PC, which I changed now, I will click on save. You will see a notification will appear on my tablet. It's saying that what you want to do. Do you want to run, or you want to always rerun? Let's select always rerun. Once we do that, now our application has suddenly changed. What this means that you can create a single application for a full team to use, and you can control how people can access this application or what features they will see. This is all what we have for today. Please, if you have any questions, any technical questions, please